Hello, algebra students. Welcome back. Thank you for being here. Flipgrid. Today's Flipgrid question of the day is at that link. Go answer it. Good fun. Also, you've already found the YouTube lesson if you're here. Good job. Now, I'd like you to think about this question and write your answer in your notes. Remember what a quadratic is? Give me an example. What is a quadratic? So think about that, write that down, and then I'm going to tell you right now what a quadratic is. Remember, a quadratic is anything that has a square in it. Could be 3x squared, that's a quadratic. 3x squared plus 2x, that's a quadratic. If I add a 9, that is still a quadratic. I could have b squared, that's a quadratic, as long as it has the square in it. As long as it has this piece, it is a quadratic. Cool. So that's what a quadratic is. Speaking of quadratics, here is our learning target and success criteria for today. The learning target is, you know what quadratic functions look like on a graph. Ax squared, and remember, ax squared just means a number, like, so example would be 3x squared, or 1/2 x squared, something like that. A is just a number. So you should know what ax squared looks like on a graph, and you will be able to graph ax squared. So today is all about ax squared. You need to know what it looks like, and you need to know how to graph it. Okay. So, we got a few vocab words to start out. The first vocab word is parabola. A parabola is what we call the graph of a quadratic function. So you see, the definition is the U-shaped graph of a quadratic function. So please put this in your notes. A parabola is a U-shaped graph of a quadratic function. So our graph will look something like this. It will look like a U. Maybe a little more skinnier at the bottom, like that. But yes, it will be a U. Okay. Alright, so pause the video, write that down, and then we will move on. I keep forgetting I don't have to pause. I'm not in a real classroom. Okay, next vocab word is the vertex. The fancy definition of a vertex is the point where a graph changes direction. So you can see that this is not a quadratic function because it's not a U. So this is not a quadratic. This is just the example that they gave. This is an absolute value function. But you can even see here. Here, the vertex is right here. Vertex. It's the place where here, all along here, the graph is going down. But once we hit the vertex, now the graph is going up. So that's what the vertex means. Here, graph is moving down, and here, graph is moving upward. So the vertex is the place. It's kind of like the bottom, because at the bottom you're going down, and then once you hit the bottom, now you're only going up. So the vertex is like the bottom of your graph, is the easy way to remember it. But the technical definition is where the graph changes direction. Okay. Alrighty. So now, before we get into the examples are going to tell us, excuse me, the examples are going to tell us to compare, because we're going to learn about ax squared. Notice first, before we talk about ax squared, I just want to talk about x squared, because these are very similar, and if you know this one, then this one's going to be easier to learn. So first, let's take a look at the graph of x squared. I'm going to make a t table. Why? So let's start with -1. Remember, 1 and 0 are easy numbers to work with, same with -1. So, the first numbers I'm going to look at are -1, 0, and 1. So let me get some axes on this graph. Something like that. We have x, and we have y. If I plug -1 in here, I take -1 squared. What is that? -1 times -1. Well, here, we'll just write it out. -1 times -1. That's equal to +1. Okay, and here, let's even graph these in a different color. So -1, 1. Cool. Okay, and that was this point right here that we just graphed. Alright, now what about 0? If I take 0 squared, that's like 0 times 0. It's just 0. Okay, so now we have another point. What about 1? If we take 1 squared, we get 1 times 1, which is 1. Wait a minute. Okay, so 1, 1, there's that point. Hang on a minute, these are the same. Why are those the same? Because a negative and a negative make a positive. So -1 squared is the same as +1 squared. Let's dig into that a little bit more. I'm gonna change colors here. And we're gonna do -2. -2 squared. If I do -2 squared, I get +4. Interesting. So -2, 1, 2, 3, 4. So there's that point. But wait. If I take... Oh, we're running out of space in our t-table. If I take 2 squared, I also get 4. So here we're over here. 2, 1, 2, 4. I think this is going to happen with -3 and 3, and -4 and 4. I think this is going to happen with all numbers and their negatives. If we did... We're running out of space. If we did -3 squared, I get 9. 1, 2, 3, 4. 9. But if I do +3 squared, I also get 9. So, I don't even need to count the boxes. Wait, this is cool. I don't even need to count the boxes. All I need to do, I know that this point right here is going to be the exact same on this side. So here, I just need to do this the same. I know it's 1, 2, 3, but it's at the exact same height. Fascinating. And that's the same for these, too. These are at the same height. Very, very interesting. Okay, I'm gonna get rid of those dotted lines. Oh. But not that point. So, I'm doing this on purpose. And that's because I want you to see that this y-axis right here is very special. We call it an axis of symmetry. Symmetry means that this side is the exact same as this side. Humans are symmetrical because I have an eye on this side and an eye on this side. I have a nostril on this side and a nostril on this side. I have an ear on this side, I have an ear on this. You get what I mean. And quadratics are the exact same way. Along their axis of symmetry, along their axis of symmetry, this line right here, they're the same on either side. So I have 0, 0 is my vertex, and then I go up like this. I go up like this. Ta-da! That is the graph of x squared. Now, it's important, one thing I want to point out, we will get to the examples, I promise. There are no points down here. None. Why? Why are there no points down here? Because anytime I square something, it's going to become positive. If I square a negative number, it becomes positive. If I square a positive number, it becomes positive. What's down here, everything down here, is negative numbers. So you won't get anything down here. Unless a negative appears up here. Otherwise, you're always going to be going up and up and up into the positive region. And that's what these arrows mean. Right here, when I put arrows on the end of the graph, it's because it just keeps going on up. If I do 4 squared is 16, so that would be, what, 9, 10, 11, 12, 13, 14, 15, 16. So here's the point for 4 squared. If I do 5 squared, that's 25, and then that's up here, and then 6 squared. 6 squared is even further up. That's why I draw these arrows, is because it just keeps going. Okay, now let's get to the examples. Moving on. Oh, okay, all right. Before we move on to the examples, one more quick piece of information. You don't have to write this down, but I do want to make sure that you know it. When a is positive, so remember we have ax squared. This is when a is positive. As long as a is positive, your u is going to point upwards and go up. Because it's positive, and positive goes up. Yes. So when a is positive, you're still going up. And we'll talk about the rest in a little bit. When a is bigger than 1, it gets skinny. It gets much skinnier. Actually, here, let's draw that a little bit differently. Here's your vertex. When a is greater than 1, it gets skinnier, and when a is a fraction, it gets wider. And we're going to see that more in a little bit. But that's what this picture, what this picture right here shows. Okay, examples. Graphing when a is greater than 0. So we are told to graph 2x squared and then compare to the graph of f of x squared. So what I like to do, I just graph this first. So let's just graph x squared first. Remember that we had 0, 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. That's an easy way to graph x squared. 0 is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then you can just put your points there. Remember, the points are the same on this side and this side. They're exactly the same because of that axis of symmetry that we talked about. Okay. And now I'm just going to connect the dots. You want there to be some curve in your graph. This is not a straight line. It's supposed to be curvy. Just like your U's are curvy, this is not a V, it is a U. Got some curve to it. Okay, so this is the graph of x squared. Awesome. Now, let's go a different color, and now we're going to graph 2x squared. 2x squared. So again, let's make our t-chart. First number I'm going to start with, because it's easy, is 0. So let's go. 2 times 0 squared. That is 2 times 0. 2 times 0 is 0. So yeah, we are still right here. This point is the same. Great. Alright, now let's do -1. We'll do -1 next. So 2 times -1 squared. This is 2 times 1, which is 2. Cool. Okay, so -1, +2, right there. Okay. Sheesh, we're running out of space. Do a different color so it's easier to see. We'll just do +1. Wait, we don't even need to do +1. I changed my mind. We don't even need to do +1 because we know it's the same on this side. The axis of symmetry we talked about. So let's do 2. We'll do +2 now. 2 times 2 squared is 2 times 4, which is 8. Okay. So now I go 2, and I go 1, 2, 3, 4, 5, 6, 7, 8. And remember, I know that it's the exact same on this side. I could do the math, but I don't even have to. I just know that whatever's on this side is also on this side because of that axis of symmetry we talked about. All right, now, you only really need 3 points to graph a parabola. The 3 you need are these 3. That's all you really need to graph a parabola. You do as many as you feel comfortable with. If you only want to do 3, do 3. You want 5, do 5. But technically, you only need -1, 0, and 1. Technically, those are all you need. Theoretically, you only need 2, but we won't talk about that. Let's not talk about that right now. Okay. So do at least 3, but you can do as many as you want. All right. Oh yes, and then compare. We didn't compare the graphs. So see how the red graph is steeper. It gets bigger faster than the black one. And that's like what we talked about up here. If A is greater than 1, you're going to get skinnier. You're going to get taller and skinnier faster. So the bigger this number is, the bigger that A is, the faster you're going to get bigger numbers. And your graph is going to get skinnier and skinnier and skinnier. Okay. Okay, so next, we talked about when A is positive, but now we have ax squared, and A is negative. That's what this means. This means negative. So, when they are negative, instead of going up is for positive, and negative, you guessed it, means we're going down. So that's why all of these graphs are pointing down, is because we have A is negative. Yes. Yeah. And the same thing when A is smaller than -1, so we have -2, -3, something like that. It's going to get skinnier, like this. And then if we had a fraction, say A was... What if A was -1/2? Then we're going to get wider out here, like the red ones. So this is like fractions. The blue is normal. The blue is normal, like -x squared. And the green is for bigger numbers, like -2, -3, and so on and so forth. Okay, so let's see an example of that. Graphing when A is less than 0. Okay, so now, we have a fraction. We have a fraction. Okay, and they want us to compare the graph to f of x squared. So let's do f of x squared really quick. And notice they're counting by 4s. So we need to take that into account. So this is 2, which means that this is 1. Okay? So when we graph x squared, remember we have 0, 0, we have -1, 1, and we have 2, 4. So this is what x squared looks like. And now let's do a different color for this guy. Again, let's make our t-table. And remember how I said you only need to do -1, 0, and 1. So those are the numbers we'll start with. Okay, -1. We have h of -1 equals -3 times -1 squared, which is -1/3 times 1, which is -1/3. So we're going to go -1 and then -1/3. Ooh, that is hard to see. -1/3. Maybe we should have picked a bigger number than -1. Maybe we should have picked 3. That might have worked out better. Okay, but 0, if we take a look, h of 0 negative 1/3 times 0 squared. That's negative 1/3 times 0, which is just 0. So we do still have 0, 0. Remember that negative 1 and positive 1 are going to be the same thing, so these are the same. And now this is really hard to see. I mean, you can see, this is all we really need, because you can see that the graph is just going to go out wide like that. That's all we really need, but I want you to be able to see a little bit better, so we're going to do another one. Let's do negative 3. We're going to do negative 3. And I'm going to erase this so I have some space. Okay. H of negative 3 equals negative 1/3 times negative 3 squared. So this is, negative 1/3 times 9. And 1/3 times 9, this is the same thing as 9 divided by 3, negative, because negative 1/3. Negative 9/3, and that is negative 3. So negative 3. Now if we go negative 3, negative 3. Ah, that's easier to see. And because negative 3 is negative 3, that means that positive 3 will also be negative 3, because of our axis of symmetry right down here. We have positive 3, positive. And now, we can draw our graph like this. Yay! Okay. So like I said, we didn't need to do these points. These down here, we didn't need to do those, but I wanted to do them so that we felt more comfortable with where our graph should point. Okay, and that looks a little too boxy. You want it to be nice and curvy. You don't want it to be, it's not that. Don't do that. You want it to be, instead of this, you want it to be curvy. This is good. This is bad. Good. Bad. Don't do that. Do this. Okay, I think you get it now. Alright. Okay, and let's see if we were right. Yes. Beautiful. So notice how f of x goes up. Whoops. Up. Because this is positive. Negative. Because this is negative, we go down. And because this is a fraction, we have negative 1/3. It goes out wider. Our first example got skinnier. We got skinnier because we had 2x squared. But now that we have a fraction here, it gets wider instead of getting steeper, it goes wider. And see how in the table that they did, they used 3 and negative 3 like we did. They also used negative 6 and 6, so they're using multiples of 3. That makes it easier. We got some fractions. We did like 1, 1/3, 1 and 1/3, and that made it harder for us to graph because they were such small numbers. So if you use multiples of the denominator, if you have 1/2, you use multiples of 2. If you have 1/5, you use multiples of 5. That does make things easier for you. Okay, alrighty. That is all I have for you today. Just graphing. Just graphing. Remember, make your t-table. Make your t-table. -1, 0, 1. Those are the easiest. But if you have a fraction, do multiples of your denominator. So then you would do -2, 0, and 2. You only have to do 3. If you want to do 5, if you also want to do -4 and 4, knock yourself out. Have fun. Have so much fun doing this. But remember that you only have to do 3. Okay. If you have questions, please ask me. Please ask me. Remember, office hours from 12:30 to 3, Tuesday through Friday. And I'm even available on Mondays if you're overachieving and doing stuff on Mondays. Just shoot me an email and I can probably meet with you. So office hours 12:30 to 3, but also by appointment as well. Your homework is just 8 questions. You can see that these ones are like example 2, because these ones, A is positive, and these ones, A is negative. So that's the only difference. These ones are like the first example, and these ones are like second example. Bada bing, bada boom. Okay. Lastly, your lunch. You are enough, just as you are. That's from Meghan Markle, but it's also from the bottom of my heart, because you are. You are enough, just as you are. There is no inherent flaw in you, no matter what. No matter, oh, my nose is too big. No, it's not. Oh, I'm not patient enough with people. Nope, you're fine. You and the core of who you are as a human being is enough, no matter what. No matter what anybody tells you. You are good enough. You are beautiful enough. You are smart enough. Doesn't mean that we can't try to be smarter, or that we can't try to be more beautiful by wearing makeup or whatever. But you are enough. Don't think that you're not enough. You are smart enough the way you are. Doesn't mean that you can't try to get better grades or you can't go learn more. But you are enough as you are, no matter what. In all aspects of your life, not just beauty and academics, but you are a good enough athlete. You are a good enough daughter or son. You are a good enough student. You are a good enough friend. Any aspect of your life, you are good enough. And I want you to believe that. It's one thing to hear it, it's another thing to believe it. I want you to believe it. So that's my launch for you today. Take it with you as you go, and have a wonderful rest of your day. Thank you for watching, and yeah, talk to you in our next Google Meet. Bye.